Welcome to Math Olympiad. Today, I will show you a couple of problems about the Math Olympiad. The topic is synthetical problem or quadratic function. Synthetical problems or quadratic function. Okay, I will to solve three problems. This kind of problem is coming in you test in Math Olympiad. So it's an international math. Okay, our first example. This problem is suppose fx is equals x to the second power plus a squared plus b squared minus 1 times x plus x squared plus 2ab minus b squared. Right? So it's an even function. Find the maximum possible. Look at this. Find the maximum possible value of the minimum value of f of x. All right. So the solution, and what is the way to try to find the solution? If follow from, for instance, if follow from the conditional that we have here, for instance, a squared. Look at this one. So a squared, right? So plus b squared, right? Minus 1, one right here. Okay, equals 0. So thinking that, and the minimum value of fx and the minimum value of f of x, all right, look, this is and then we have to write a squared, this one, a squared plus 2ab minus b squared, right? That one. So let here, let just write it a equals cosine of the angle, this angle, and b equals sine of this the same angle, right? So then here, then just follow all the steps in this kind of problem. We need to be careful, all right? And then let's write a squared plus 2ab minus b squared here equals cosine square of this angle, all right, the same angle, plus 2 sine, right, 2 sine of this angle, sine of this angle, less cosine the same angle right there, minus sine squared of the same angle, all right, all different. So this will be equals, now if we need to simplify here, we will have cosine 2 of angle this plus sine 2 of the same angle, right? So equals here square root on number 2 sine, open parenthesis here, 2 this angle, the same angle, plus pi divided by 4 cross right here, and then less or equals than square 2, right? See where the equality holds when Actually, it's done. I will erase this information to write it some conclusion. Look at the answer right here. So just I want to make some conclusion in our problem. See, so as a conclusion here, I will erase this everything, and then let me write some conclusion in this problem. So the conclusion is where here, where is continue, where the equality. Look at this, the equality. See, holds. What is the holds when is a equals cosine pi divided by 4. All right. I mean, yeah, 4. No, it will be here is 8. All right. Yeah. Just check the information back in the video. So this one 8 and b. I mean also the same thing, and sine pi divided by 8. So cosine and sine. Okay. Therefore, so it's our conclusion. The maximal is the question here. We have to find the maximal possible value. So the maximum possible value or the minimum, remember, of the minimum value, the minimum value of f of x. Remember the conclusion that we got it is square root of number 2. All right. So that's our conclusion in our first example. Okay, let me show you another another example. Okay, let's try to find the solution or solve another problem. I will to solve 3 problems on Math Olympiad. Remember, this kind of problem is a little complex. We need to pay attention and then be very smart to find the best way to find the solution in this kind of problems. Today, I told you this problem belongs to the synthetical problems of quadratic function. Let me write example number 2. All right. Example 2. Let's write this problem here. This let a function. Let this marker is not work. Google. Let a function. I will write the whole problem. Let's write f of x equals. Let's write ix squared plus bx plus c. Right? Problem like this. Suppose here this function suppose as f of x here. I mean, and these signs f of x. All right, f of x less or equals than 1. Less or equals than 1. Here is like in this way. Okay, it is very, very important for all values of x belong to this point, -1, 1. Okay, this is an interval that following inequality. So the following inequality always hold. Okay, that's our problem. This with S. Okay, this is our question. So what is the inequality? The inequality, it has, I will erase it, the problem. So we could find only the the solution, let's write ax, look at this, plus b, and this in this way, plus c, less or equals than 3, right? So now the solution. So look at our problem here. I will erase it because I don't have enough space here to write all solution of this problem, right? See the problem? All right, I will erase our problem. Keeping your video, and then if you have a question, just look it back. Remember, it's a problem number 2. So the solution of the problem number 2, solution to problem number 2. Let's write from from negative 1. Let's write here from negative 1 equals let's 8. Let's write 8. Why 8? Let's write 8 minus b is b plus c. Okay. F1 right here. F1. A1 is equals a plus b no plus c. See. Here is positive, here I think it's negative here, minus b, positive right here, yeah, and let's write c, or f of x, f of, no c, we have negative 1, positive 1, and 0, negative 1, positive 1, and 0 equals here, should be C. All right. So then if we continue working in our process, let's write 8 equals 1/2. I write here 1/2 f of negative 1, f of negative 1 here, plus 1/2 of f of 1, okay, positive 1 here, minus f of 0, right? So now b, this is a b equals, look at this kind of problem, it's hard, we have to think deep, right? All right, b, let's write 1/2, same thing, f of 1, no, negative 1, right? B is 1, no, it's a different way. So this not, so b, look at the problem, it's 1 minus 1/2. Now it's minus, it's positive here, and this minus 1/2 f of negative 1. Yeah, like this, and then we have c. What is c? C is equals f of 0. All right, so like that. So with this, we from here we have some process here. Hence, now very important here. We have c right there. Absolutely, c equals. We will have f of 0, less or equals than 1, okay, and as very important, just follow all direction, and we have a plus b here, a plus b equals, we have here 1/2 f of negative 1, look at this, and then x plus 1/2 right here, plus 1/2 f of 1, now f of 1, right? F of 1 x plus 1/2, look at this, plus a 1/2 of, yeah, we already write 1, so now it's here x f of 0, right? F of 0, yeah, missing x, f of 0 right here, f of 0, x plus 1/2, again, plus 1/2 of f of x. 1/2 of f of x should be there. Is 1, and the first one is positive 1 plus 1/2 of x, or negative 1. Yeah, negative 1. Here close with that sign, the absolutely. So now simplify all this data. Oh my God. Simplify here. If we simplify here, we will have now equals, here we will have 1/2 here. All right? Parenthesis x minus 1. Close parenthesis. F of negative 1 right here. Plus, again, we have to write 1/2 here. Open parenthesis, x minus 1. X. Here is not, his minus, his plus 1. The first one is negative or plus, and then here is no, negative minus 1, here is plus 1, right? Look at this difference times f of f1 minus f of 0 x. All right, so close here. So next step, minus or equals, again, here we have to write, but outside this 1/2 now of x minus 1 right here plus 1/2. Oh, but in this case, look at this. Here it's a little different right here. And this, we have 1/2 right here, and then also this absolutely here, the sign in this way. Plus here again 1/2 this absolutely x, but plus 1. Close right here, this sign, plus 1. Plus, again open f of 0. And then close it, the sign. Minus absolutely of x, right there, okay? So, again, we have to simplify here, so less or equals. So one more step here, right? 1/2 now is not the absolute, so x minus 1, and this way parenthesis, plus 1/2 parenthesis x plus 1, okay, plus 1 equals 2. All right? So therefore, here is a conclusion. Therefore, let me, if this its color has ink, let's write yeah, it has color, so write write a plus x plus b, close it, a plus b plus absolute value c. Here our answer is less or equals than 3. That's the solution to our this problem, question number 2. All right, so that was a problem number 2. See, that was our conclusion. Remember the question at the beginning. The question to this problem was we have to the function f of x, ax plus bx plus c. Suppose absolute value f of x is equals or less than 1 for all x belong to remember the space -1 to 1, -1 to 1. Okay, we have to show that x belong to -1 to 1 for you when the inequality always hold that ix plus ix plus b plus c less or equals than 3. All right. So that was a question. So this is right. This kind of problems we have to be very smart, and I'll show you some kind of problems. In this case, 3 problems for this topic. This topic for Math Olympiad. Let's go, and then one more problem. Example number 3. Let me write another example. Example 3. Suppose right here. Suppose f of x is equals a is x squared plus bx plus c. All right, and then satisfy this. Satisfy absolute value f of x e less or equals than 1 is same to the problem before. For all x belong to, look at this space, 0, 1. Look at that point. Find the maximum here. We have to find the maximum value of absolute value A plus absolute value B plus absolute value C. All right, absolute value C. Yeah, we have to connect it with the example number 2. It's almost the same right here. So the solution, let's see the solution. Let me write. I will try to do everything without erase the problem, right? So we have since here we have this great information here. Let me write f of 0 equals c. Remember, I am connecting this problem from the last problem, from problem number 2 which I did. So this is equals 1, 4, 8 plus 1 half b plus c. Okay, and then the last one, f1 equals, this is like a plus b plus c. Okay, we need to be very smart in this problem. Now the last let me write another data here. Look at this. This is very important. So a is equals, we need to know how much is a. Look at this. Here a is equals 2f of 1. All right, plus 2f of 0. All right, minus 4f of 1/2. All right, that's 8. So now b should be 4f, okay, of 1/2. All right, minus f of 1, okay, minus 3f of 0. That's b. C, look at this. C is equals, it should be equals is equals 0. C f of 0. All right, so here I'm going to divide our space in this in 2 sections. I don't want erase it. I don't want to erase it on this section. Let me go try to with this data solve our problem. So hence here. All right, let's write the problem. So a absolute value 8 right there equals 2f of what? 2f of 1 plus 2f of 0, right? Minus 4 f of 1 4 1 half. Not 1 4 1 half. Yeah, we're talking about it's right here. So now b. So I mean this one and that one, this with this data, actually we have to write this here and then Navi. Let's to simplify here. So should be here less or equals let's I will to simplify all these data here, and then if we simplify here, we will have here 2 less or equals than 2 absolute value f of 1 plus 2 as f of 1 plus 2 here f of 0 see, plus 4 here, and then f of 1 half okay, four of f of 1 half. Close it. Now b, we will have now b absolute value b here is will be equals let's write here everything here equals 4. Is we are talking about b here is equals 4 f of 1 half, all right, minus f1, right, f1 minus 3f of 0, right, 3f of 0, and then close it here. So now we have to simplify that one. This is a, this is a b. If we simplify, we will have here less or equals than immediately 4, right 4. Here is f of 1 half, closer ahí, absolute value there, plus open absolute value f of 1, closer there, f of 1, plus 3 absolute value of f of 0, closer by there, less or equals than 8. Okay, that's b. So now c, we have c right here, so it's equals absolute value f of 0, right, f of 0 less or equals than 1, okay, it's c, so a, b, and c, all right. So now we will have everything here. So we have absolute value 8, all right, plus what else? Plus b, all right, plus b plus c, okay, you have all variables there. So less or equals than 8, okay, first one. Oh, in the first step here, I'm missing here. Here is, we have to write, let me write it with a different color. Here is, the first one is less or equals than 8. This one is belong to here, after here. Okay, is A. All right, so it's A. And B is equals, is A to negative, less or equals than 8. And C is less or equals than 1. So we have here, let's write 8 plus 8, right? B, A, B, and then C plus C. How much is C? Is 1. So what is the answer? So the answer here equals, right here is equals 70. This is our solution, see? That's our solution for our problem number 3. Remember this problem, the base of this problem to solve the problem is was in the problem number 2. I did problem number 2, and then after continue with the number 3, example number 3 is complete all information right here. I keep it all information to you, and then step by step, A, B, and C. Look at the question. Suppose f of x equals A x to the second power plus bx plus c. Satisfy absolute value f of x less or equals than 1 for all x belong to 0, 1, right? So find the maximum value of a plus b plus c. We have to find the maximum value of the a plus b, a plus c plus b plus c, all right? So this is the maximum value. The maximum value is 7, right? So thank you so much. Math Olympiad, Mondays and Tuesdays at 3 p.m. I am trying to help you in a different kind of math problem, okay? So Mondays and Thursdays at 3 p.m. Monday and Thursday, 3 p.m. Thank you so much. See